Hi there. In this video, I'm going to tell you all about the Snowflake Query Profile. This video is one of the modules of my Snowflake training course, Mastering Snowflake Fundamentals, Insights and Best Practices. I will describe how to read the query profile to help you diagnose performance issues, how Snowflake executes queries in parallel and uses a hash join operation for joins, and which statistics you need to focus on to help you improve query performance. After watching this video, you should have a clear understanding of how to read any query profile and make your Snowflake SQL queries fly.
In this module, I want to go through the Snowflake Query Profile and how you can interpret the profile of your queries. It's really all about reading the signs and knowing what to look for. So let's start with a relatively simple query profile. So here on the left, we've got a fairly simple query. It's going to select the order status, sum of total price from orders for a given year, and then do a group by and an order by. And here in the middle, we have the query profile and the statistics associated with it. And what we'll do is we'll go through each of these and explain exactly what to look for. And then later on, we'll talk about the statistics and what these actually mean in some detail. With any query plan, you start at the bottom. So start at the bottom and work up. And it starts with a table scan operation. And in this case, it's reading from the orders table. And what this represents, it's reading the data possibly from the remote storage or from the local storage from the SSD, but effectively it's a table scan. When you read data, it is then filtered, and really these statistics relate to the table scan operation. The scan progress at this point, the query is actually finished, has been 100%, and there's nothing scanned from the cache. And the next step is the filter clause. So this is where we execute the work clause and we limit the number of entries returned. We can see here we've got 22 million going in and 22 million coming out. So this is retrieving data and then filtering the entries to only bring out the data for this particular year. It's curious because you'd expect this number being fetched to be lower than this number. The reason why these are exactly the same is because actually this filter is being pushed down into the table scan. So your work clause there has been filtered out, actually physically down here, but it's represented here as an additional step. The next step is the aggregate. So that's where it's going to sum the results. And here is where you do the sum of total price. This and the group by operation. This step here indicates the amount of time it spent waiting for CPU, and this indicates that it spent a considerable amount of its time processing, and that's where this step was spending its time, the aggregate. And then finally we have the order by. So this is where we're actually sorting the results, and this is also adding to the processing time. And then finally we have our results being returned to the end user. So let's look at a more complex example, and then I'll go into a bit more detail of the actual components within the query profile. So here we've got a more complex SQL statement. It's doing a join of the customer and the orders table, 150 and 1.5 billion rows. And it's doing a count star. And this is what the results are going to look like. And this is what the query plan is going to look like. So you'll notice here that unlike the previous step, there's actually a fork in the road, and that's because of this join operation, which is going to join the results of the two tables, the orders table down here, and then the customer table here. So here we see the orders table and the customer table. And the thing about this, again, we start from bottom up, but it's actually illustrates an interesting point. Each of these operations, each step, is actually being executed in parallel. All of these boxes represent independently running processes, and it's going to retrieve a few thousand records and then push them up into the next step and up to the next step and up, so that these steps can all be executed in parallel. Because Snowflake runs in parallel across multiple nodes, and each node has at least 8 CPUs, that means it can do an awful lot of these operations in parallel. If we look in a little bit more detail, we can see, as well as the name of the operation, the table scan or the join filter or the filter or the join, we can also see the sequence. You can see here that, as well as the type of operation, like this is a table scan, this is a filter, this is a join, and this is an aggregate, we can also see that what it's actually doing is a table scan. It's step 5, and it's reading from the orders table. This percentage here shows the percentage of time that it spent actually working on this operation. So here it spent 9% of its time table scanning the orders table, 77% of its time scanning the customer table, because this is the much larger of the two tables. But both of these are executed in parallel, and it's a vectorized operation, so it's sending thousands of rows up, and all of these boxes represent independent processes. The next step after fetching the orders is to filter them. So this is where the order date is between this date and this date. And as I've said before, it actually shows 19 million going out. In fact, if we were to execute the count star of here, I'm sure you'd find a lot more than 19 million rows, because that filter is being pushed down into this step. It's just represented here as a separate filter operation. In order to join the data from orders, it's then got to have some customer data. So the customer data is being fetched. As I say, these are both fetched in parallel, and it then executes what we call a join filter. I'll explain that in another module around the advanced tuning, but effectively there are 28 million rows retrieved in this particular operation. And then you have the join operation, and here we can see it's actually spent 6.4% of its time doing the join operation, and this is where it's actually joining via these keys. Every join operation in Snowflake is a hash join operation, and we can see here we've got the larger table to the right. So what Snowflake would always try and do, we'll always try and get the smallest result set on the left and the larger on the right. What a hash join does is it reads all these entries into memory, does a hash of the key of this data, in this case the customer key, and then does a table scan of this result set and matches those entries in memory. And you can see here there were 19.32 million rows returned, which indicates that there's an equal join between these two. So you got one entry for every order, and we're also adding the customer information onto it. The next step going up the tree is the aggregate. So this is where we're doing the sum and the count operations. And then we have the sort operation, when we're ordering by the first column, the market segment. And then finally, we're returning the results to the user via the results cache. That's how to understand a query profile, and more complex query profiles just build upon these principles. Let's have a look at the statistics that were shown alongside the query profile. Effectively, there are two areas of the statistics. These shows you the total execution time, the total time spent executing the query. This can be different to the elapsed time, because the elapsed time includes time spent compiling the query, etc. And the rest of these percentages are the percentage of time waiting for things. In the processing, it's all waiting for CPU time. Local disk I/O means it's waiting for the local SSD. Remote disk I/O indicates how much it's waiting for remote disk. And then synchronization is when it's getting data synchronized between nodes within the virtual warehouse. The initialization is the time spent compiling the query and initializing the processing beforehand. So here we can immediately see that a large chunk of the time is spent doing remote disk I/O. If we need to tune this query, this is where we need to focus. If we look down in the statistics, the scan process shows the percentage of data scanned. So if you refresh the screen and show the query profile multiple times, you'll see this gradually increasing until it gets to 100%. The bytes scanned is the total number of bytes scanned across all of the tables in the query. And the percentage from the cache is always the data cache. So that's the percentage of all the data which is actually retrieved from the data cache. In this case, it was 0 because we ran this query on a cold warehouse. These next two are really important. This shows the bottom, the partitions total is the total number of partitions in all of the tables in the query, and the partition scanned is the number we needed to scan in order to satisfy our query. So this shows we managed to eliminate a fair number of these in this query. Priority entries, the ones you really need to focus on, are the total execution time and the local and remote disk I/O, especially the remote disk I/O, because this shows that the query was I/O bound, and anything you can do to reduce the remote disk I/O is going to make a significant difference. Occasionally you see queries with very high processing rates. That might indicate you're doing massive sort operations, or maybe even multiple sort operations, and that's where you need to tune your query. If we look in the statistics, remember I said before we spend about 80% of our time waiting for I/O. That was because we scanned 700. We did manage to eliminate a fair few of those, and these are priority statistics. This will give you a really good indicator of how much I/O the query is doing. And for the most part with Snowflake, executing queries quite often are I/O bound, and anything you can do to improve this elimination, in particular by using the workflows, is going to improve your query performance. Okay, I will see you in the next module. As I said, this module is just one small part of an entire Snowflake training course by me, John Ryan, at Analytics Today. It covers a huge range of subjects, and I'm happy to deliver this either as pre-recorded self-paced training or as a live instructor over 3 days. So if you or your company are interested in some of the best Snowflake training available, just like this video, you need to visit our website, and don't forget to like or subscribe to this video and get notified of new material. That's www.analyticstoday. Let's talk soon. Thanks.